I thought of something, a new way to look at this. All right? Let me see if I can show you. Let's say I have some integral 4 to 6 of, I'll just call it g of x so we don't get confused here. And as we saw before, I can just say from 4 to 1 of g of x plus from 1 to 6 g of x dx, right? This is always going to be true, no matter what gx is. That actually is integrable. So, okay, so let's plug these in here. So, that's not what I want to do. Let me see if I can think about what I want to do. Think before I write. I want to say, it's not going to work. Or is it? Wait a minute. Maybe what I want to do is plus 4 equals, that would be 1 to 4. That's what I was thinking of in the shower. Okay, if everyone take a look at this and can everyone see this? Is everyone convinced this is correct? You can see it? Okay. So, all right. So now, let me just plug in here, 1 to 4. That's 8. And 1 to 6, that's 5. And let's just call this x, because we don't know what it is. So x has got to be equal to 3. But x isn't really what I want, is it? 6 to 4 of f of x dx is equal to 3. First of all, these are reversed, right? I want 6 to 4. So 4 to 6. So that's minus 3. And actually, we want 3 times that. And, the 3 can go inside or outside. But we multiply by 3, we should get minus 9. I guess again. So, I don't know. Maybe it wasn't that much better than the. All right, let me do it again the way I would tell you to do it formally. Okay. I don't know if that was such a good way of explaining it. It seemed clearer in the shower, but okay. So I want 4 to 6, 3f of x. 4 to 6, 3 x dx. So that's, of course, 3 times this integral 4 to 6 f of x dx. And now we want to split it up. So it's 3 times the integral from 4 to 1 f of x dx plus the integral from 1 to 6 f of x dx. And one of these is not the way we want it, right? 1 to 4, 1 to 6, 1 to 4, right? So if I switch the 4 and the 1, that changes the sign on this to negative. So 3 times negative 1 to 4 f of x dx plus 1 to 6 f of x dx. Okay, so now I can take the numbers from the book. 4 to 1 is 8. So this is minus 8. 1 to 6 is 5. So minus 8 plus 5 is minus 3. Times 3 is minus 9. I've beaten that to death, haven't I? Okay. Other questions about homework? Okay, I can move on here a little. Okay, I want to mention there's going to be a quiz on Tuesday. I may have forgotten to mention that there was homework from this last Tuesday. It's on my website. You can pretty much count on an assignment almost every day. So you can always look on the site. I'll try and remember to mention it, though. And it's not due till Tuesday anyway. So there's an assignment from Tuesday, an assignment from today that'll be due on Tuesday. We will go over it in class beforehand, before the quiz. So if you have questions on that homework, if you're confused by it, you'll have a chance to ask questions. If someone sends me an email over the weekend and say, can you put up an answer key to the homework? I will. I'll have to create one, but I will. Again, the homework is for practice. It's not a test. So, okay. I have to see where I am. Are there still any questions from the worksheet I gave out Tuesday? I know I put up an answer key, and I know there were some errors. Somebody pointed one out to me, and I fixed it, but there were more errors. So, anyone? No? Okay. All right. So we're gonna learn a few new things today. That I think are relatively fun. I want to remind you of something you should have run into in your 48 A, B, and C class, or your pre-calculus class, or maybe even your trigonometry class. I'm going to talk a little bit about odd. Get rid of this. Odd. You gotta find a good one. And even functions. Anyone remember what an odd function or an even function is? Remember the definition? Okay. Let's start with an even function. An even function is a function f of x where f of minus x is equal to f of x. So let's take a look at a few examples. We have a nice simple example. F of x equals a constant. Right? Clearly, I say f of minus, say c is 5, and f of minus 1 is 5, and f of 1 is 5. Right? F of everything is 5. So f of x equals c is an even function. Next, let's look at f of x equals the absolute value of x. Well, that's pretty clear, right? Like, if f is minus 1, if x is minus 1, f is 1. F is positive 1, f is 1. So for every, absolute value turns a negative into a positive, so these are going to be equal. And I want to draw a little graph here, just to give you a rough idea what these look like. I guess it's going to have to squeeze a little here. So here's f of x equals c. Here's f of x equals the absolute value of x. Right. Next, let's look at f of x equals x squared. So very similar to the absolute value function in that anything you plug in becomes positive, right? So f of minus 2 is 4, and f of 2 is 4. And that's going to be true for any x. If f of minus x or f of x are going to be equal. So again, put a kind of a rough graph here. And I hit the bottom, haven't I? Right? I shouldn't write any lower than this, should I? So for number 4, I'm going to use the cosine of x. Should be everybody's favorite even function. Draw a little picture here. Kind of what the cosine of x looks like. And it goes on, of course. Okay, what do all these graphs have in common? Just looking at them. They have something in common that you should know. Anyone? Yes?
They're reflective to the
Yes.
y-axis.
Yes. If you think of the y-axis as a mirror, whatever's on one side is on the other. Or if you like, the graph is symmetric about the y-axis. Right? It's symmetric. That's a property of all even functions. And if you see a graph, and it's, it goes both ways. It reflects over the y-axis. It is an even function. Okay. Moving right along. A little wasteful here of board space, but that's okay. More of it now. All right, so what's the definition of an odd function? And by odd, I do not mean unusual. Okay. Well, f of x with 0, that would be, write the definition before I give you an example. An odd function is a function, f of x, where f of minus x equals minus f of x. Or, if you prefer, you might want to think of it this way, minus f of minus x equals f of x. Okay, that's an odd function. All right, example number 1, f of x equals 0. Well, that's trivially true because f of anything is 0, and minus 0 is 0. So we have a simple example, not a very good one. Number 2, let's look at f of x equals just plain old x. The graph of which looks like this. So just a simple example, if I said f of minus 1, that would be minus 1, which is minus f of 1. And that's going to be true for all values of that function. Yes?
Would number 1 be an even function too?
Yes, because maybe you can't see this far.
So it's in
All constant functions are even, right? But not all constant functions are odd, just this one. Oh, there's a little pearl of wisdom there too. I hadn't really even put into the lecture. It's possible to have a function which is both odd and even, right? We see one. This is a function that's both odd and even. So for those of you who want to go on in math, your homework for whenever you want to do it is to prove that if a function is both odd and even, it's this function. It's a simple proof. So I'm just making a proposition here that there's only one odd and even function. Okay, let's take a look at another familiar function. F of x equals x cubed. That kind of looks like this. And again, I think I'm going to run out of board space here. Finally, everyone's favorite odd function, f of x equals the sine of x. What does that look like? Okay. Note here, if you're dealing with a monomial function, f of x equals some constant times x to the n. I think that's the correct term. Any of these functions, you can look at n, and you can tell right away. If n is odd, it's an odd function, right? Like x and x cubed. If it's even, 2 or 4, then it's going to be an even function. I think that also works if x is like -2, -4. Okay. Additional comment here. Additional comments. Not all functions are odd or even. All right? For example, simple example, like most functions are not odd or even. x equals x plus 5. I said, f of 0, no, not f of 0, that's not going to work. F of 0 will. I say f of 1, that's 6. I say f of minus 1, that's 4. So clearly f of x and minus x have no simple relationship, except that given by the function. So not all functions are odd or even. Another comment, if you have an odd function, say odd, times an even function, or odd function divided by an even function, you get an odd function. This is actually different from numbers. If you multiply an odd and an even number, you get an even number, right? If you multiply an odd and even function, you get an odd function. And here we have, I guess, we'll say it's your second favorite odd function. It's the tangent of x, which is an odd function divided by an even function. And recall the tangent of x looks something like this. It looks a little like x cubed, except those are asymptotes, right? And then it's periodic, so it's going to repeat. All right. What can we say about the graph of an odd function? I mean, we know that there's a symmetry for an even function. Even functions, they're way down here. The y-axis creates kind of a mirror that an even function reflects on. What about an odd function?
Symmetric to the origin.
Oh, that was said so well. Did everyone hear that? Thank you. Symmetric to the origin. The origin means 0, 0, of course. Okay. Why? Okay, that's it. Questions about review on odd even functions? Good. Is everyone done with all this? Good. Why all this interest in odd and even functions? The reason is because sometimes knowing whether a function is odd or even may help you in finding an integral. Why would that be? Let's look at the integral from 0 to a of f of x, and compare it with the integral from a to 0 of f of x. That's not what I want to do. Sorry. Let's first look at an even function. I'm just going to use the cosine because I said it's my favorite even function. And what if I wanted to find the integral from negative a to a of the cosine? It doesn't really matter what a I pick. Well, I know that this is the same as the integral from minus a to 0 of the cosine of x plus the integral from 0 to a of the cosine of x. But I can switch this, right? This is just from 0 to minus a, but I have to put in a minus sign. Now let's look at this diagram here, this graph. I'm integrating from 0 to a. It's this piece. I'm integrating from 0 to minus a. This piece. They're both the same. Right? So I can change this to a, except, if I'm integrating this way and I reverse it from here to here, I have to change this to a plus. So I get that the integral of this even function, or any other even function, from minus a to a is just 2 times the integral from 0 to a of that function. This can be very convenient at times. All right, let's look at the same issue for an odd function. Again, I'll use my sine function because I like it. And I guess this is no mystery here. I'm going from minus pi to pi. Well, now, here's my minus pi. Now, I have some negative area under the curve from negative pi to 0, which is just the opposite of the area above the line from 0 to pi. So what must this be equal to? 0. We can just change this so you can say any a, really. Any minus a. Let's look at a integral that you think you don't know how to do. Let's go from negative 5 to 5 of e to the x squared over x to the 9th. Now, if I put this on the quiz, you might panic. You might go, I'm going to find the antiderivative of that? Heck, that's ugly. Put it in your calculator and I'll give you the right answer. But you don't really have to do any of that, right? So, look, this function, e to the x squared, is an even function. Right? Whether I plug in negative 1 or 1, I get the same value. This function is an odd function, right? If I plug in a negative value, I get a negative. Plug in a positive, the same value, I get the positive version of that. I have an even divided by an odd, so it's an odd function, and I'm integrating from some a to some other a. This has to be 0. So you do know how to do that now. Okay. Any questions about this? This is going to come in handy, I'm sure. All right. Let's take a somewhat obtuse example. So this is kind of a more real-world example where this will help. What if I want to integrate from -2 to 2, x to the 4th minus 3x squared dx. Well, this isn't actually that hard. You could just go ahead, find your antiderivative, plug in all these numbers, and you'll get the right answer. But we can do some simplification before we get there. The first thing I want to do is divide this up into 2 integrals, x to the 4th, and, it's a minus, okay, that's fine, minus 3 x squared. Oh, wait, did I write the problem down right? No, I'm sorry. This is a cube. If this wasn't a cube, the problem would be too easy. Okay. So what kind of function do I have here? Odd. So I already know this integral is just, okay? This function is even, so I know I can simplify it a little bit. I can just say this is 2 times the integral from 0 to 2 of x to the 4th. And now this is much simpler. There's much less work to do here. The antiderivative is x to the 5th over 5. I want to evaluate it from 2 to 0. So it just becomes 32 over 5 minus 0. So, a nice simplification. All right, let's take a look at another example. Similar kind of example. What if I was looking at the integral from negative pi over 2 of cosine of x minus 4 sine cubed of x. This is, at this point in your career, you don't really know how to deal with this. Not looking at the symmetry here, you wouldn't know how to do this. But again, we can break this up. Cosine of x dx minus 4 sine cubed x dx. Let's think about this now. The sine is an odd function, right? So if I cube it, I get what kind of function? Odd function, right? Everyone see why that is? if I know f of x is an odd function, if I cube both sides of this, what do I see? F cubed of x equals -1 cubed f cubed negative x. So this is, of course, -1. So f cubed of x is also an odd function. If I just squared it, it would be an even function. So what happens when I, symmetrically integrate an odd function? What is it? There's all this here. Zero. Right. So now all I have to do is find this integral, which again, I can simplify it. It's just going to be 2 times the integral from 0 to pi over 2 of cosine of x dx. All right. Antiderivative of the cosine is the sine. So 2 times the sine of x from 0 to pi over 2. What's the sine of pi over 2? Everybody should know this. 1. 1 minus the sine of 0, which is 0. So it's just 2 times 1, it's just 2. Okay. What I think I'm going to do now is I'm going to pass out a worksheet, and oh, is this the one where they messed me up? Yes, but it's going to work out good. Oh, this is great. The copy machine kind of burped, and instead of, like putting 2 sheets and you say staple, and it just kind of sucked in 2 sheets and just printed it. So I had actually 2 sheets here, but they're not together. It's fine. So, okay. Let's take a few minutes and work on these. Did it get to you? You don't like it? Did you run out of them? Oh, okay. I'll grab the extras. Extras. Have some extras. Okay, anyone missing one? You need one too? Oh, you also? Effective teacher here. You didn't take that class in, how to pass out papers? Oh, you got it. Okay. Everyone good? Take a few minutes. If it takes that long. done, right? No? Not done? 10, right? Cool. Okay. Your check. Okay. Home car here? Oh. Did I see Kevin here? I guess Kevin's not here. Okay. Okay, anyone still need more time on this? Would you just open the door? I don't know, here, someone's out there having smoke, having come in. No one's here? Okay, close it. Sorry?
Did you want me to close the door?
Yeah. It won't lock. Okay, well. A little side issue, administrative issue I have to mention. I assume anybody who's gotten an ad code has already used it, so that's not an issue. If you want to drop the class, you need to do it by Friday at 5 p.m. There's only one person I have to talk to about whether whether they're going to drop. If you don't come to class, I'm supposed to drop you. Okay, I think that's it. All right. What do I do with my extras? Oh. Okay. I don't even think we need to do some of these on the board. Someone want to tell me what number 1 is? 0, yeah. It's an odd function, integrating from -3 to 3. Okay. How about number 2? That's what, an even function minus an odd function? No, it's not.
So it's just
It's an even function minus an even function. It's not. Yeah, it is. Yeah. So how do we simplify that? This is what? The integral from where to where? 0 to 2, but you got to multiply it by 2, right? So 6 minus 1. Okay. How about number 3? It's 0 again, right? I don't know what number 4 is doing there. It's an even function, but I'm integrating from 0 to pi, so I think we just did that on the board too. That should be pretty simple. Okay, any other questions about integrating odd and even functions? About even functions? All right, it's 7. Why don't we take a break now for 5 or 10 minutes? And watch me be wrong. Okay? So, if I was to go around the room, make believe, and I said, so Frank, how old are you? 20, right? And then, and I said, England, 19. And I kept doing this, right? For the whole class, right? You know, maybe someone's 23. And then I divide by however many people are in the class. Let's say, just a guess, they're 40. So that gives me the average, or the mean, right? Average. They both mean the same thing. But this is what we call a discrete problem. 1, 2, 3, 4 discrete people, each have an age. But let's say I'm in a car, and I'm traveling along at some speed, and I don't know, I slow down and get gas, and then I, take off, and then have to, hit a speed trap, and so this takes, let's say, 4 hours. Maybe I'm, I don't know, driving to LA or something. So the area under this curve, since this is a velocity curve, the integral of the velocity is, does anyone recall this? We have really distance, yeah. Or if you want to go the other way, if you take the distance and you find the derivative, you get the velocity, right? So if we add all this up, let's say this is 200 miles, this is 400 miles. If we add this all up, you get 600 miles divided by 4 hours. You get that I traveled at 150 miles per hour. You have a Ferrari or something, or what's that new electric car? Tesla, yeah, Tesla. Outrace the police. So this value here, this is it's not how fast I was going, right? I mean, I was going even faster. I was going 200 miles an hour here, and then I had to slow down, and I wasn't going at all. This is the average, right? But it's different from a discrete average, right? I actually have to integrate, right? So this gives us what we call the idea of the average value of a function. I don't want to erase this picture yet. So if I have some function, f of x, defined on some interval a to b, and I find the integral from a to b of f of x, that of course is the area under the curve. But if I then divide this by b minus a, the length, right, of that interval, that becomes the average value of f. That's it. That's the definition. We'll sometimes write this, we'll use this, let's say f, with a little bar over it. So let's do another example. I like this example because even though I don't have a Tesla and I probably can't drive to LA at 150 miles an hour, it has some reality to it. This next problem is kind of silly, but comes from the book. There's a hiking trail. Has this elevation. $60 minus x cubed minus 650 squared plus 1200 x plus 4500. I guess the idea is you have kind of a mountainous area and trail that kind of goes back and forth, and something like that. And x is just the distance you've traveled along it. And the question is, what is the average? This is, this function tells you how high you are up on the trail. So the question is, what is the average elevation, or f, whatever, between 0 and 5? And to solve this, you merely have to use this formula, which would tell us it's the integral from 0 to 5 of 60 minus x cubed minus 650 x squared plus 1200x plus 4500 dx, now divided by the distance, which is 5 minus 0. By the way, if I ever gave you a problem like this on a quiz, I mean, I'll say exact if I want exact, but this kind of problem where it's elevation, it's not exact anyway, right? So I would just use the calculator function. If you like doing computations, I'm sure everybody does, right? You go ahead and do it exact. Okay. Average value of a function. That's all there is to it. However, for the next section, I need to remind you of something. Anyone recall the mean value theorem from, I think you would have had this in 1A. Remember what this theorem tells us? Uh-oh. Ah, yes.
Isn't it the average slope between 2 points must equals the slope at some point in the line?
So I have some kind of function that is continuous and differentiable. It's a nice function. And I picked 2 points on that function. I picked 2 points, and I draw a line through them, and that line has a slope, right? Delta y over delta x. The mean value theorem tells us that between those points, somewhere on this function, there is a point where the tangent has the same slope. That is, there exists a C. I guess we haven't done a lot of, what's the word I'm looking for? We haven't done a lot of logic here. But this backwards E means there exists a C such that derivative at C, this is my point C, point A and my point B, is equal to f of B minus f of A over B minus A. F of B minus f of A being delta y and B minus A being delta x. So that's what the mean value theorem, when someone says the mean value theorem, this is what they mean. However, there's another mean value theorem. We have the mean value theorem for integrals. It's a little different and it's a little more relaxed. It says I have some function f of x, and this function actually can be a little less nice. It doesn't have to be continuous. can have little jumps in it. But I take a look at the integral between 2 points A and B. And I want to know what the average value of that is. You know, I think I'm wrong about this. I guess it does have to be continuous. Thinking of a different theorem. It's a continuous function. And I look at the average value of this. And the mean value theorem for integrals says that there exists a C between B and A, being less than or equal to or less than, such that f of C equals this value. In other words, this function, the area, has, this function has some average value on this interval. And there has to be a point C where f of C is equal to the average value. Now, I kind of find this a little obvious, and I'll explain why. We're not going to do a proof, but I have some function between A and B, right? At some point on this function, there's a number greater. There's the greatest value of f of x, right? And at some other point, say down here, this we'll call f of x max, is f of x max. And since this is continuous, every value of every value between f of x max and f of x, wrong thing here, it has to be on this line somewhere. In other words, it's continuous, so it runs through every value. But clearly, the average has to be less than the maximum, and it has to be greater than the minimum. So if every value between the minimum and the maximum is on this function somewhere, then clearly the average has to be there. We'll give you a hint on how you might want to prove this. So. Okay, let's see an example problem. So I have some function, f of x equals 2x times 1 minus x. And I'm looking at this function on the interval from 0 to 1. And I want to know at what c is f of c equal to the average value of f. This is not very hard, right? I can just say, well, look, 2c times 1 minus c is equal to this average, which I can compute. 0 to 1, 2x times 1 minus x, x over minus 0. Okay, so let's do this. So this is 2x minus x squared. The antiderivative will be x squared minus x cubed over 3, 0 to 1. So this is 1 minus 1/3 minus 0 minus 0 over 2/3. And we divide by 1. Now we just have 2c times 1 minus c, so 2c minus 2c squared equals 2/3. This is now an algebra 1 problem. Let's multiply through by 3 and divide by 2, right? So 3c minus 3c squared, bring the 1 over, minus 1 equals 0. Write it in kind of a more standard form. Well, I guess I should multiply through by minus 1 too. So I have 3c squared minus 3c minus 1 equals 0. And I'm not going to factor this, I'm just going to use the, what formula? 9 minus, I did something, oh no, it's minus, so it's plus 12 all over 6. I don't think that's the answer they were looking for. Probably means I made a terrible mistake here somewhere. Oh, I left that at 2, didn't I? Nobody caught that. Okay. That's 1/3. Now all this is wrong. So, what about 3? So 6c squared minus 6c plus 1. Let's cut that. I don't think this is going to work any better. 6 plus 1 squared root of 36 plus 24 all over 6, 50, 60. 1 plus or minus square root of 60 over 6. I'll leave it at that. So there's actually 2 points. This looks like one of those problems where you probably should check. No, because one of these points isn't on the interval, right? So it has to be 1 minus square root of 60 over 6. That doesn't look right. That doesn't look right either. Okay, homework problem. Find out where the professor went wrong. I will do this too. Okay, I have some more problems for you to try, and we'll go over them, and then we'll be done for today. So, see how you do better. Guess I'm getting really rusty. So, do calculus, I can't do algebra anymore, I guess that's the problem. 2c times 1 minus c equals 1/3. c minus 2c squared equals 1/3, or 6c minus 6c squared equals 1, which is 6c squared minus 6c plus 1 equals 0. And therefore c equals 6 plus or minus the square root of 36 minus 24 over 12. This is 1/2 plus or minus square root of 12 over 12, which is 1/2 plus or minus 6 over the square root of 3. Great square root of 3 over 6. So So that's either about 0.7, .788, or .211. Okay. So both those points are valid. So I'm going to put the assignment for Tuesday and the one for today on board. They're both for next Tuesday. Okay, anyone not finished with the sheet? All right. I'd like some volunteers to do the problem board. Volunteers? Anyone? 5. Number 6. Number 7. Number 8. Anyone? Maybe I need to bring a box of chocolates, right? And give this out. No one wants to do any of these? No one wants to show how much smarter they are than everyone else? All right. So, average value, f of x equals x squared on interval -1 to 1. So we integrate from -1 to 1. X squared, oh, that was an even function too. 1 minus -1. Right? So this is x cubed over 3 from -1 to 1 over 2, or 1/3 minus -1/3 over 2. So that's just 1/3. I see I intruded on the other person's space here. Okay. Any questions on this one? Pretty straightforward. F of x equals square root of 1 plus x. Again on interval -1 to 1. So you want to find the integral from -1 to 1 of the square root of 1 plus x dx over, again, over 2. Now, we probably haven't really done much with anything like this yet, have we? How would I find the antiderivative of the square root of 1 plus x? Take that over on the side here for a second. Well, an obvious nominee would be, since what we're talking about is x plus 1 to the 1/2, a nominee might be x plus 1 to the 3/2, and maybe there's a constant in there. I don't really care about the constant quite yet. I'm just kind of guessing here. And to check my guess, I find a derivative, right? So what's the derivative of x plus 1 to the 3/2? Well, that's going to be 3/2 x plus 1 to the 1/2 times, using the chain rule, the derivative of x plus 1. Which is conveniently just 1. So I'm really close. I just need that factor of 3/2 to go away, right? So -1 to 1. this is pretty easy to solve. There's 2 to the 3/2. That's square root of 8. 2 times square root of 8 over 3, all over 2. 2 drops out, and it's just the square root of 8 over 3. I mean, sometimes just simple guess like that will make things clear. This one should be even easier, shouldn't it? F of x equals e to the x. We want the average value. So I'm going to integrate again, minus 1 to 1 of the x divided by 2. So that's just e to the x between minus 1 and 1 over 2. That's just going to be e minus, e to the minus 1 is 1 over e over 2. That's like e squared is minus 1 over 2. 2e. And then finally, one of these kinds of problems. Absolute value. Well, this is a good example even without it being an average value problem. F of x is equal to the absolute value of the sine of x, this time on the interval from 0 to 2 pi. So we want to find the integral of the absolute value of the sine of x from 0 to 2 pi, but over 2 pi minus 0 over 2 pi. Well, what do we know about the sine of x between 0 and 2 pi? I mean, it kind of looks like this, right? From 0 to pi, it's positive. Pi to pi over to 2 pi, it's negative. But we want the absolute value, so we're going to have to split the integral and make this part positive, right? So we're going to go from 0 to pi of sine of x. Now, kind of turn it over, we're going to subtract. Going from pi to 2 pi of sine of x all over 2 pi. But we can be a little smarter, actually, because we know once we turn it over, it's just the same thing, right? It's really, I mean, you can do this out, but it's really just this, just 2 times this area. Okay, so what's the antiderivative of the sine of x? Minus cosine of x. So let's remember all the rest of it. We've got 2 out here and a 2 pi. Cancel. And we're just going to go from 0 to pi. So negative cosine of pi. What's the cosine of pi? 1. So the negative of negative 1 is just positive 1. Now we're going to subtract the negative cosine of 0. So the cosine of 0 is 1. We're subtracting negative 1. We're just adding positive 1. So it's just 2 over pi. So the average value from here to here, or actually, quite honestly, it would be the average value from here to here. Or if you think about it, this is symmetric too, so it's also the average value from 0 to pi over 2. It's just 2 over pi.
Interesting.
All right, any questions about average value or anything else? All right. Well, we're done a bit early. I'll be here for questions. We spend a little time with this, and a little time with the homework, and I'm sure you'll all be fine on this.